Hello, Mr. Rhino, you alright? So we have a talk about the longest substring without repeating characters. Longest substring without repeating. Okay, we talked about this 2 days ago. Eric, Ryan, and what's the longest substring that contains no duplicate numbers?
ERICRYA. No, wait. ICRYA.
Yeah.
N.
Okay.
Yes.
Yeah, because look, ERICR, R appears. Yeah?
Teamwork.
Okay, so yeah, we talked about this 2 days ago. Longest substring. Substring continuous, yeah? As opposed to subsequent, which does not have to be continuous, but substring has to be continuous. And we talk about two solutions, true false. There are Cn1 plus Cn2 number of, this is total number of substring, right? Cn1 means that the size, if there are n characters, we pick one out of n. And that's the substring of size 1, single character, there are n choice. Cn2 means that we pick a left index and we pick a right index. So there are Cn2 of ways of picking the index, one for the left, one for the right, and then once we have this left and right index, we have the substring. So let's represent the number of substring more than one characters. And if we simplify this, that's going to take n times n plus 1 divided 2. This is the total number of substring. And look, we have this n square thing, yeah? N square thing. Even we divide it by 2. This is the inner scale of O(n) square, okay? So it takes O(n) square to iterate O(n) square to prove us all the substring. And for each substring, we need to check if it has all the unique characters. And that's going to take O(n) time. So overall, the time complexity for this approach is the O(n) qubit. Okay? And we talk about sliding window. The idea is that we could expand the right pointer as much as we can when the character is not in the window. Yeah.
Yeah.
I let you finish your business, otherwise it's too noisy. Okay?
Alright. Thank you.
Tell me when you finish, okay? Because it's too noisy.
Finish!
Okay. The idea is that we have this left pointer and then we have right pointer, right? Listen. So we move the right pointer as long as the character in the right pointer is not in the window, right? So for example, ERIC, the current window is that. But R is in the window. If we don't move the left pointer, if we don't shrink the window, no matter how far we move the right pointer, the substring is not valid. Am I right? Can you imagine that? Alright? Yeah. Look, ERIC, my current window is here. Now R is in this window, right? So if I don't move the left pointer, what happens? I keep moving the right. The R is still in the window, right? So the only way to make the substring valid is to shrink, to move the left pointer to the right, to shrink the window until the current R character is not in the window. Does it make sense this way? Yeah? Yeah? The time complexity is O(n). Why is that? So think it this way. The left, we have two pointers. And the pointer goes to the right. The R pointer goes one way. The L pointer goes one way. So the maximum number of distance the both pointers travel together is O 2 times n, right? So that's the inner scale of the O(n) linear. Define, okay, longest substring S. First of all, n equals length S. L pointer equals R pointer equals 0, right? The answer at the beginning we have 0. And then we use the window while R not reaching the n. Then we have to check while SR is in the window, right? So if the character at the right pointer is in the window, what do we have to do?
Move it forward.
Now this R is in the window, so what do we have to do?
Delete ER and then.
So what do we have to do? Move the
L
to the right, right? So window dot erase.
Ryan.
Don't remove, okay? Remove SL and then L plus equal 1, okay? Window dot add SR R plus equal 1, okay? And then also we have to remember the longest answer length of the window, right? and then return answer. Yeah? Yeah? This is not new, yeah? Okay? Make sense?
Yes.
Yeah.
Yes.
But yeah. If this R is in the window, if it is, then we check. We keep moving the left pointer, right? We don't know. We move the air pointer. We don't know when, right? We don't know when the window contains only unique digit, right? Right? Alright? So we have to check. But here, I'm telling you, look, if we have a dictionary, D, if I tell you D, R, the character R, last appear position is here. 1. Okay. Look, I'm visiting this R.
Yeah.
So look, I'm telling you the last R, I know, right? It's here. Can we just erase every characters to R, right? Because look R. I know R, the previous R is here. So can I just move the air pointers and erase everything up to R?
Yep. Yep.
Right? Okay, so look, in this way, now we know how many characters we need to remove, right? Right? Okay, so this is the slightly different, but both are okay. Okay, so how do we do it? We use the D. In order to do this, we need to have this dictionary. D equals dictionary. Okay? We still need the left, the right pointer. Wire. So before this, so X will be equal. The current character is SR, right? Okay, and then the I, the last appear position for X is D dot get X minus 1 plus 1. Okay, this is a little bit tricky. D is the dictionary. And we want to retrieve the position, the key of X. X is the current character. By default, right? Because we are declaring the dictionary, just using the very simple syntax dictionary. Or we can do this, D equals this. This is the same. When the key is not in the D, right? You throw an error unless we use the get, D dot get. The second parameter is the default value when the X is not in the key, right? So when X is not in the key, so when this letter has not appeared before, first term return -1, +1, that will be 0. If this X has appeared before, it will return the index, and the +1 will be the index after it. Okay? So wire, air, then smaller than I, right? So we want to remove everything. So win dot remove as air plus equal 1. Okay, so slightly, this is slightly different here. And then after that, we have to remember this position. So it will be D X equals R. Okay, this is going to here. We updating the last position of X is current position. It's current index. This is the index. This is the current character. Okay? Yeah.
Yeah.
We are removing every character up to including the last R. If every time we do this, then we can make sure the window contains only unique characters. Look, the window, L and R, right? Window, this is window A. We don't have anything of A appear, so that these would return I will be 0, right? I will be 0. So it actually doesn't go in here, doesn't go into the loop to remove every characters up to the previous A, right? B, AB, the current window. ABC, current window. ABCD, current window. Right? B, okay, look. B appears before, right? So we're removing everything to up to B, right? So we're removing this.
And then we remove it.
Okay.
Priorities.
Removing, okay, then the current window is CDB, right? Okay, C.
Yep.
So remove everything up to C, right? Okay. E, F, G, okay, got it?
DBC.
All the rest are the same. The only difference is this bit. How do we shrink the window, right? The previous method, we just check if the window does not contain this SR, right? Then if it contains SR, we keep removing. We are using an additional space, D dictionary, to remember the last index of the current character S. Okay. What have you learned?
We learned
What have you learned? What's the problem? What have you learned?
we learned
about the same thing as the
What's the problem and what have you learned? What's the new thing that you learned today?
So you-
about the 2 pointers, how to delete the priorities differently.
Yes. Okay. So what's the approach today taken?
We're using 2 pointers.
Yeah, it's still 2 pointers.
We are raising the copy and before it.
Okay, so can you explain it a little bit better, Eric? Do you know how to explain this?
So basically, we given this like letter thing,
Yeah.
and then you have to
Okay.
contain a box that the longest one that has all of them have to be unique
Yeah. Okay.
letters. Like this, in this case, it's
ICRYAL. Yeah. Okay. Okay. So how do we use the 2 pointer?
you have this thing window.
Yeah.
You start from
Empty window. Yeah. An E and an ER, an ERI, ERIC. Okay. Okay. Then what's next?
and then you already got R here, so
We remove everything.
you remove this thing.
What thing? So how do we make sure?
So just cut it.
Yeah, I know. Now I'm here an R. This is R. Okay, so how do we make sure the window contains the no more R? So
We have this.
Eraser.
yeah, so how do we remove? Which letter do we remove?
The
Okay, so we know the DR.
first copy and before it.
Yeah. So DR is the last position. So it tells you where R is the last R.
And
You remove everything, yeah, after
Before.
yeah, and then you keep doing that, right? This is new today. The day before yesterday, or 2 days ago, we talked about this. We haven't used this DR thing dictionary, right? We instead we just check why SR in the window, right? So we just check if this R is in the window. Then if it's in the window, so we just keep moving the left pointer. We just keep shrinking the left window, right? Yeah. Okay, so which method you think is better? I mean, just some thoughts. Which method you think is better?
I like.
Both are okay. Both are 2 pointer. Both are sliding window. Both are on space, on time. But they're slightly different. So which one you think is better? Which one makes more sense?
The
More,
shorter one.
the shorter one. So which one is shorter one?
This one.
Which one? The left or right? Today, so sorry.
Right.
Right. You think this is better, right?
Yep.
This is shorter, yeah, because we don't need to have another additional dictionary to remember the last position of the current character, right? But this one we have additional.
But you said there's no right or wrong answer.
That's right. There's no wrong or right one. They're just personal opinions, yeah.
Yeah.
Okay, but so which one you think better? Ryan likes this one. You think which one is better? Shorter one is which one? Which one is shorter one? It's slightly the same. Which one is shorter one?
My one. My one.
This
Nice
one, yeah?
one,
Yeah, yes. Because this one, as I said, we have to additionally declare a dictionary, okay? Okay, that's it for today. Bye-bye.
Bye.
Bye-bye.